this video I will be explaining how to solve a very simple ordinary differential equation. A differential equation is an equation that have derivative. In this case, the equation that I'm going to solve will be an equation when the derivative of a function is isolated in one side of the equation. So how to solve a very simple differential equation? Solving a differential equation is finding an expression for the function that have the derivative. So finding an equation that doesn't have a derivative. For example, in this case, find a function for y. Solving differential equation is one of the most important applications of the integral. In applications, we are going to find things like this. When we know, for example, the rate of change of a function respect of a variable, or we know the marginal function respect to a variable, for example, the marginal cost or the marginal revenue. If we know the expression for the marginal revenue, this can be written in mathematics terms in this way. The marginal revenue is the derivative of the revenue respect to the quantity produced. So in this case, if we have a problem of marginal revenue or marginal cost, and we know the expression for this marginal cost or this marginal revenue, actually what we have is a differential equation. And to find the cost or to find the revenue is solving the differential equation. So let's see how to solve an equation like this. So an equation like this, y prime, so the derivative is isolated at one part of the equation, at one side of the equation, can be written obviously as dy dx equal g of x. I like to write it in this way because in this way reminds me that I can type this in terms of the differentials. So the differential of y will be equal to gx dx. So when we type the expression like this, so that is equivalent to the previous one, we say that we have separated the variables. So the y's are one side and the x at the other side of the equation. And you can apply integral both sides of the equation. And if you apply integral, you get the integral of dy equal the integral of gx dx. And the integral of dy is just y. So you can type that y equal the integral of gx dx. And if we solve this integral, we have found an expression for this y. So we have solved the differential equation. So that's what we are going to do. I'm going to show you two examples. The first example is not an application problem. We have the derivative of x equal 10x. So we know an expression for the derivative. So obviously we can type it dy dx equal 10x. And this reminds me that I can separate the variables, so I can type that dy equal 10 dx. And I say it reminds me because it's like if you multiply by the x both sides, like the differential of x both sides, and you get this expression. Okay, so now that you have this, you can apply the integral both sides, and if you apply the integral, and you know that what we are going to have at one side will be y, at the other side will be the integral of 10x dx. And I know that to get this integral, what I need to do is add 1 to the exponent, and the final exponent will be also typed as a denominator. So it will be 10x squared, so y will be equal 10x squared over 2. Or 10 over 2 multiplied by s squared, plus a constant of integration. So obviously, when you get the integral of dy, you get a constant of integration. And when you get this integral, you get another constant of integration. But anyway, you can subtract the second constant minus the first, and you're going to get a constant of integration. So it's not necessary to type two constants of integration. So will be enough to type in one constant of integration. And obviously this is 5x squared plus 6. A value of y then depends on two things, depend on x and depend on a constant of integration. There are some problems in which you know a value of y for a special value of x. If that happens, if you know what is the value of y, for example, when x equals 0, then you are going to get what will be the value of the constant of integration. And then you can actually express the value of y respect to x. So what I'm going to do is showing you practical problem in which you can get the constant of integration. So let's see a problem like this. And this problem will be one when we know the rate of change. So we know an expression for the rate of change. This is the sample. Home ownership as a percentage in certain countries was 75% in 2000. If the rate of change of the ownership of over time can be modeled by this equation, so the rate of change of the ownership will be minus 0.09x plus 0.60 when x equals 0 corresponds to the years 2000. So this x is the time, and this x will be equal 0 in the year 2000, will be equal 1 in the year 2001. So this x is in years. And this is the rate of change as a percentage of home ownership. So this is a problem in we know the rate of change. And we know the rate of change, then we can get how will be the home ownership in that country at whatever moment in percentage. Notice the value of the home ownership was of 65% in 2000. So for x equals 0, we know a value of the function. In this case, let's call it y. So we know the value of y when x equals 0. So this is a problem in which you know an expression for the rate of change, and also you know the value of y for an special value of the independent variable, that in this case is the time x. Okay, so in this problem there are two questions. The first one is find a function that defines the ownership in year x. So find an expression of the ownership in whatever year. So at whatever time, the time in year. So we want to know the expression. So we want to know the function of the ownership. So we are going to solve this differential equation. And second, we want to know what was the ownership in 2016. So when x equals 16, because if x equals 0 in 2000, x will be 16 in the year 2016. Okay, let's solve this. So the first thing to get the solution is just solving this differential equation. So I'm going to type the differential equation that we originally have in this way: dy dx equal minus 0.9x plus 0.60. I separate the variable, typing that the differential of y will be minus 0.9x plus 0.60 dx. And then get the integral both sides. I know that this one will be y, and the other side will be the integral of this function, dx. And the integral of this will be minus 0.9x squared divided by 2. So it will be, and this will be 0.60x. So we have here the value of y will be 0.9x squared over 2 plus 0.60x plus a constant of integration. And obviously this is negative 0.045x squared plus 0.60x plus c. Now we need to know what will be the value of c. In this case, it's possible to know the value of c because we know one information for what will be the value, what is the value of y, and a special value of x. So we know what happened when x equals 0. When x equals 0, the value of y equals 65%. Since in 2000 the ownership was 65%, then we can substitute here when x equals 0. Remember that for the years 2000 x equals 0 for this year, so it will be when x equals 0, y equals 65%. So when x equals 0, y equals 65. So in my equation I can substitute x by 0 and the value of y will be 65. So we're going to have this. This is 0. When you multiply 0.45 times 0 is 0. This is 0 again. So c equals 65. So we have a value of c. So I know now that the value of y anytime will be equal y equal minus 0.45x squared plus 0.60x plus 65. So this will be the value of y. This will be an expression of the ownership at whatever time, in whatever year. For example, in 2001, I substitute x by 1. In 2002, I substitute x by 2, etc. So this answers question A. Question B is, what was the ownership in 2016? So for answer question B, the only that we need to do is substitute x by 16. So let's answer here question B, and we know that ownership in whatever time is this. This is the expression for the ownership in whatever time. And in the year 16, so in 2016, we know that x equals 16. So we make a substitution x equals 16, and we get then that y will be at that time will be minus 0.045 16 squared plus 0.60 multiplied by 16 plus 65. Use your calculator and you will notice that y equals 63.08. So in the year 2016, the ownership was 63.08%. And that answers this question. If we have an expression that gives me the rate of change at whatever time, and we know the value of y when x has a special value, then we are going to get an expression for the function that we are looking for, and we are going to know the value of this function at whatever value of the independent variable. I think with this I finished this video. I hope you have found it useful. Thank you.